All right, this is lesson 5.1, solving systems of linear equations by graphing. All right, a system of linear equations is a set of two or more lines with the same variables. Okay, and specifically raised to the same power, right? So in this case, x plus y equals 7, 2x minus 3y equals negative 11. That's a system of linear equations. They both have an x and a y, both raised to the first power. Okay? All right. First thing we're going to do is to 5 a solution to the system of linear equations. All right, so if they ask you that, you're literally going to just plug in the point into both equations for x and y, right? So they give you a point, it's an x and a y, and you're gonna plug it into the equations and see if it works. So we have our first equation from up there, x plus y equals 7. If we plug it in, x is 2, y is 5. Does it work? Yes. Makes it a true sentence. Try the second one. 2x minus 3y equals negative 11. 2 times 2 minus 3 times 5. So I put 2 in for x, 5 in for y. I get 4 minus 15. And that is also true. So that means, so we're going to write that now. If the point works in both equations, then it is called a solution to that system of equations. So the solution to a system is going to be a point, and that point is where those two lines would cross if we graphed them. Okay, so we're going to write that last. This means that 2, 5, that's a point, right, that we tried in both of them. 2, 5 is the point where the two lines would intersect on a graph. Okay, that, because think about it, on a graph, if the point is on the line, right, that's what we say, the line is made up of a bunch of coordinate points. So if they both have this point in common, then that has to be where they cross each other on the graph. All right, so very important. A solution to a system of equations is the point on the graph where those two lines would cross. And If they just give you two equations and ask if the point is a solution, you plug it in. If it works, then it is a solution to that system of equations, okay? All right, so we're gonna solve the system of equations by graphing. So now they're not going to ask us if the point works. Now we have to find the point that works for both of the equations. So we have y equal negative 2x plus 5 and y equals 4x minus 1. Okay, so we're going to make our graph. Okay, your first step then is to graph both equations. All right, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1. Okay, so how do we graph these? Well, they're in slope-intercept form. Perfect. So this one has a y-intercept of 5, and it has a slope of negative 2. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Okay, we'll draw that line. So this line is right here. And then this one has a y-intercept of negative 1. So I'm going to put a point here. It has a positive slope though of 4. So I'm going to go up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, so that is this line, and we want the solution to that system of equations. So what are we looking for? We're looking, where do they intersect? Do they cross somewhere? Absolutely, right here. Okay, so they intersect at 1, 3. That's the point of intersection. So the point 1, 3 is the solution to the system of equations. Shh. Okay, we can check it. To make sure it works. Because what did we do on the first page? We plugged the point back in, right? So you can always check it. So if we have y equals negative 2x plus 5, put in the point. Y is 3, x is 1. We get 3 equals negative 2 plus 5. 3 equals 3. Okay, let's try the other one. Y equals 4x minus 1. Y is 3. X is 1. 3 equals 4 minus 1. Yes, that checks as well. Okay, so once you graph it and you find the intersection, you can always plug it back in and check to make sure it works. All right. Okay, if, let's see, a roofer is buying 15 bundles of shingles and 8 rolls of roofing paper. And when they bought that was their first purchase. It cost $640. Okay, and then they needed some more. So they bought then 8 bundles of shingles and 2 rolls of roofing paper. And this time it cost, so the second purchase, they paid $296. Okay, so that's the information given to us. They want us to find the price per bundle of shingles. So what would 1 bundle of shingles cost? And we're going to find the price per roll of roofing paper. Okay, so for 1 bundle of shingles and 1 roll of paper. All right, so what are we trying to find? You always want to define your variables, right? So we want to know the price of 1 bundle of shingles and the price of 1 roll of paper. So we're going to define our variables. We're going to make X represent the price of 1 bundle of shingles, and we're going to make Y represent the price of 1 roll of roofing paper. Okay, so that's going to be our X and our Y. It's the prices. The next thing we're going to do then is write equations. Okay, so we're going to take the information given to us and we're going to write some equations. So I know that X is 1 bundle of shingles. Well, what did they do on their first purchase? They bought 15 of them. So however much that costs for 1 bundle, we bought 15, so we need to multiply it times 15, right? Y represents 1 roll of paper, but we bought 8 of them, or the roofers did. So we would multiply the cost of 1 roll times the 8 that they bought. And how much did they spend altogether? $640. Okay. How about the second purchase? X again is the price of a bundle of shingles. This time they bought 8 of them. Y is the price of a roll of roofing paper. This time they bought 2 of them, and they spent $296. So we have 2 equations, right? And we are going to graph them. We're going to graph them, right, to see where they intersect. Graph to see where they intersect. And when we do that, that's going to give us an X and a Y, and it's going to tell us what we want. We want the price of both those things. Okay, so I'm going to draw my graph over here. Now, why am I only drawing the first quadrant? Because we're dealing with a real world problem and we don't need any negatives. Okay, down here I'm going to count by 4s. Four, 8, 16, 20, 24, 28, 32, 36, 40. And here I'm going to count by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay, now I kind of did that backwards because you need to figure out what your y and your x and y intercepts are, right, in order to be able to know what your graph needs to look like. So we are going to take these equations that are in standard form, right, and we are going to solve them for their intercepts. So remember, when we put a 0 in for x, 0 times 15 just gives me a 0. That leaves me with 8y equals 640. So if I solve that, I get y equals 80, right? Okay, so that means my y-intercept is 80. And then let's do the same thing again, except this time we're solving for x. So 15x, if I put a 0 in for 8y, I get 15x equals 640. Divide by 15. That x is going to equal, what did I figure it out? Let's see. About, what did I do? 42 something. Okay. So now I can graph. This is going to be a little past 42, so it's going to be a little right in the middle there, between 40 and 44. Okay, so I'm going to connect those. And then I'm not going past either axis because that goes into the negatives both ways, so I don't want to do that. Okay, that was my first one. Then we're going to do 8x plus 2y equals 296. If I put a 0 in for x, I get 2y equals 296. If I divide by 2, y is going to equal 148. So 148, all right there. And if we solve the other way, 8x plus 2y equals 296, and we put a 0 in for y, this time we have 8x equals 296, divide by 8, x is going to equal, I got a 36 something. Okay, so we're going to draw that line. And if you notice, where do they cross? That actually worked out better than the first time I did it. Okay, they cross at 32 for my x and 20 for my y. So what does that mean? So if x is 32, that's $32, right, for one bundle of shingles, and y is $20 for one roll of paper. Okay, so that's a way that you could graph two equations to see where they meet and get the solution, right, to the system of equations that way. Okay, the key thing is, though, right here, you have got to what was I trying to say? Tell what the variables are going to mean, right? Define your variables. Whatever whatever the question's asking you for, that's what your variables are. Okay, so we wanted to know the price for a bundle of shingles and the price for a roll of paper. That has to become our variables then, because that's what we're solving for.